Hello everyone, welcome back to my channel. I'm Florian, a passionate AI researcher focused on underlying principles and insightful content. Today, we're diving into an exciting innovation in AI, something called Garlic. It's an IG system that incorporates advanced data structures. So grab a snack, get comfy, and let's break it down. Imagine you're in a huge library, and you're trying to find the most important events from a 1,000-page book. You could ask two assistants for help, right? Assistant A, using traditional IG methods, hands you random pages based on keywords. But here's the catch, they don't explain how the pages are connected or their context. It's like a random page here, and another one there, no big picture. Now, Assistant B tries a different approach. They create a tree of information, going down one branch at a time. But this approach has its own problems. If you need something from another branch, they have to go all the way back to the top and start over, wasting time. So, what's the solution? Enter Garlic. A smart librarian, essentially. Think of Garlic as the intelligent librarian who creates a hierarchical map of the book, highlighting the key events and how they are all interconnected. When you ask a question like, "What did the protagonist go through?" Garlic can quickly navigate the most relevant paths and give you a clear, concise answer. Now that we know how Garlic works, let's dive into why this is an innovative breakthrough for AI and IG methods. Here's how Garlic works in detail. It uses a method called hierarchical weighted directed acyclic graph, a mouthful, right? But stick with me. First, Garlic splits the document into smaller chunks. Each chunk gets summarized into an information point, or IP. These IPs are organized into a multi-level graph. The beauty of it is, instead of relying on traditional embeddings to find relevance, Garlic uses the power of attention weights from LLMs to guide the search. This makes the retrieval process smarter and more efficient. By using attention-based retrieval and dynamically controlling when to stop the search, Garlic ensures you're getting the most accurate and contextually relevant information without unnecessary computational overhead. Garlic operates in two main stages. In the first stage, Garlic creates a summary graph. Each section of the document is summarized into bullet points or IPs, which are then connected to each other based on how closely they relate. The second stage is dynamic graph search. It uses a greedy best-first search, constantly evaluating whether it has enough information to answer your query. The cool part? Garlic knows when to stop searching, which keeps things efficient. In other words, the retrieved nodes are fed to the LLM. Using KV caching at no extra cost, the LLM checks if enough nodes are present to answer the query. Once sufficient nodes are collected, the final answer is generated. So, what's the big takeaway here? It's a step forward in AI's ability to process long documents, especially when you need detailed context or need to navigate complex relationships between events. In addition, retrieval based on attention weights rather than embedding similarity may be explored in broader scenarios. Of course, no system is perfect. There are some challenges to consider, like the potential for attention score normalization to be inconsistent across contexts, and the reliance on LLMs to decide when enough information is gathered, which can vary depending on query complexity. In addition, HWDAG's multipath retrieval can lead to redundant processing due to path overlaps. And the graph's construction is computationally expensive, requiring extensive pre-processing and lacking efficient update mechanisms for document changes. That's all for today's content. I hope these technologies provide new ideas for your projects or research. If you enjoyed this video, please give it a thumbs up, subscribe, and hit the bell icon to stay updated with our latest content. Thanks for watching, and see you in the next episode.